Okay, this is lesson 2.1. Unit 2 already. Unit 2 will go much quicker than Unit 1. Not as long. All right. We're not going over the warm-ups. They do have to be done for your notes. So if you have problems, please come in here, or you can also go to the PACE lab if you need to. Here we go. For every input, there's exactly one output. Means the same input cannot have different outputs. What does that mean? Nothing. You can use a vertical line test to see if a graph is a function. Draw a vertical line down the graph of your relation. If it passes through only once, then it's a function. If it passes through more than once, then it's not a function. What does that mean? Here's what it means. Let's go here. I want to explain this first. Okay, the input-output thing, this is what we mean. Your x is your input. Your y is your output. Okay? Your y equals mx plus b, that's your function. So, what we mean is, you're only looking at the x values. All your x values have to be different for it to be a function. Look here. 1, 1. This is not a function. Why not? Because it has two x values that are the same. I do not care about my y values. Look at number 23. 5, 4, 2, 1. This is a function. Yes. Wait a minute. You got two zeros in your y. That's your y. I don't care about the y's. I'm only looking at the x's. Okay? If all your x's are different, it is a function. So now we're going to do the vertical line test. This is the vertical line test. It's very easy. If a vertical line passes through your function only once, it's a function. So is number 1 a function? Yes. Is number 2 a function? Yes. Is number 3 a function? No, look. This vertical line right here passes through it twice. No, that's the vertical line test. That's pretty simple, right? Okay, number 7. Is number 7 a function? Okay, no. Is number 8 a function? What about number 5? Is that a function? Yes, yes. This is a parabola. It is a function. Okay, now we get to these dots. What am I looking for? Well, I'm looking for stackers. I don't want any stackers. You see here, look. There's a stacker. That means no, not a function. Why is it not a function? Well, think about the x value. What's my x value here? 0. Well, this one's 0, this one's 0. Not a function. Do I have any stackers in number 12? No. So yes, this is a function. Now, let's look at number 13. I know, but hold on a second. Look at the stacker. Is that open or closed? Open means don't include that. So this one right here and this one right here do not share the same x value. Because this is at 2, but it's open. So that says nope. Now look over here. Now this is at 3. Do these two lines share the same 3? Yep, because it's closed. So that's a 3 and that's a 3. So this is not a function. Look at number 15. They share the same x value, so no. If you have any sharing of the x, it is not a function. Each x value can have only one value for y. If the x repeats, the y must be the same for it to be a function. That's important because they're going to try to trick you. If the x values repeat, the y values for that x have to be the same. What does that mean? Well, here's your x and y. So I have 3, 2, 3. So this 3 equals 0. This 2 equals 1. And then this 3 equals 0. Guess what? These are the same points. This is 3, 0. This is 3, 0. They're the same points. Even though your x's repeat, they have the same y value, so they are a function. Let's look at this one. 3, 0, 2, 1, 3, 6. These x values have different y values. They're not the same point, but they have the same x point, so it's not a function. So it'd be like this. 1, 2, 3. 1, 2, 3. Negative 1, negative 2, negative 3. So if I have a point here at 3, 1, and I have another one at 3, negative 1, they share the same x value. That means it's not a function. And then let's say I have it here and have it here. So that means this line, that's not a function. So if they share the same x and the same y, it is a function. To me, that's kind of cheesy. I don't like that, but whatever. Okay, look at these. Is this a function? 2, 4, 6, yes. All your x values are different. It is a function. Negative 1, 0, 6, yes, it is a function. All I'm doing is looking at the x's. Now, 3 and 3, that means it's not a function, right? Check your y's. Your y's are different, so no, this is not a function. If your y's would be the same, it would be a function. 19, a, x, c, negative a. Yes, this is a function. All my x values are different. What do you mean? They're all letters. I don't care. Letters are numbers in this world. All right. We've already talked about this. This is the same thing. You're looking at your x values. Wait. Sorry, this is different. Complete the table so that it is a function. So what can I put here? What can I put in this right here to complete this table? I can put 3 and 1. Or I can put any number that is not 3 or 7. I can put 5 here. And then I can go 0. I don't care. So here's the key word. Is a function. So over here, I can go 4, negative 1. And that still keeps it a function. Complete the table so it is not a function. Negative 2. Now, with my negative 2, can I put 5 here? No. 6. 6. 7. Is that okay? Yeah, because 6 has a 2. So as long as I don't put 6 and 2, I'm okay. I can put 6, 7. All right, kids. If you have any questions, please come in. Have a nice day. Bye-bye.